Okay, here we go. This is a flashcard video, and I'm hoping what it does is it'll help you to practice the flashcards on your own. I'm going to try to go at a pace where you have a few seconds to give the answer yourself. Obviously, the first time through, you may not anticipate the answer, so just kind of watch it the first time and then start quizzing yourself on these flashcards. This won't exhaust everything you need to know for the final, but if you can master these flashcards and do those easy questions in 30 minutes or less and feel pretty familiar with the other questions on the review, then you should do pretty well on the final, okay? So please let me know if you have any questions on these or you feel like there's something that I missed. Okay, here we go. S is sample standard deviation. Mu, population mean. Sigma squared, population variance. S squared, sample variance. X bar, sample mean. Sigma, population standard deviation. When do we use unadjusted variance or standard deviation? For populations in StatCrunch. If they are samples, we just use plain old variance and standard deviation. But for populations, we use the unadjusted variance and unadjusted standard deviation. P hat, X over N. This is actually in your formula sheet, but we don't always know to look for it. X is the number of successes, N is the number of outcomes. What is the mean and standard deviation for a z-score? Remember, z-scores are in terms of standard deviation. So the mean is 0, standard deviation is 1. Okay, this picture should look familiar, like the picture you see when you do calculators normal and StatCrunch. What words are associated with this box on the lower right? Probability, proportion, percentile. Percentile, the red is always on the left. Percent, area, z sub alpha. We did not have any z sub alpha questions on the review, so I wouldn't worry about that one. Okay, how would you find the mean, median, and mode in StatCrunch? Stat, summary stats, columns. What else can you find there? You can find Q1, Q3, IQR, standard deviation, variance, unadjusted standard deviation, variance. That's where we found just a whole bunch of our statistics or parameters. Okay. All right, here we go. This one is a little more than a flashcard, but it's super important. If 40% of students do not like online courses and 2 students are randomly selected, what is the sample space of possible outcomes and their probabilities? So use L for like, D for dislike. What would that look like if I took 2 people? It would either be 2 dislike people, 1 dislike and then 1 like, or 1 like and 1 dislike, or 2 likes. How would I find the probabilities? The dislike was 40%, so that's a 0.4 times 0.4, which is 0.16. 0.4 times 0.6 is 0.24, 0.6 times 0.4 is 0.24, and 0.6 times 0.6 is 0.36. Something to note, if you add all these up, you'll get 1. If you don't, you did something wrong, okay? Notice that in here, at least one person who likes would be this one, or this one. This is the only one that doesn't have at least one person who likes online courses. Okay, so this was that little shortcut question. How can you find the probability of at least one yes? Notice how this becomes sort of an opposite thing. It would be 1 minus the probability of all, which is the opposite of at least one, no, which is the opposite of yes. So in our previous example, yes might have been they liked online courses. So the opposite would be they did not like online courses. So these two would be the opposite, and at least one, the opposite would be all. So in our previous example, it would be both, because there are 2 of them. If I had 7 of them, it would be all 7. Okay, so I would practice that one with that type of question that you saw in the review. Okay, what are the requirements for a binomial experiment? There are 4 of them. The experiment is performed a fixed number of times. The probability of success is the same for each trial of the experiment. The trials are independent, and there are 2 mutually exclusive outcomes: success or failure, or late or on time, or I don't know, boy or girl, whatever, depends on the study. Okay. How do you calculate the probability of a binomial experiment using StatCrunch? So if somehow you figured out in the problem that it's a binomial experiment and they're asking you to find a probability of something, what would you do? You would do stat calculators binomial. And once you get there, it's pretty self-explanatory. I think you'll remember at that point. How do you find a z-score given an area? So, and this is a little tricky because we had a formula for finding z-score, and we used that based on the context of the problem. And then we also would do the calculator normal to do the z-score. The context of using the calculator was that they either gave you an area or gave you the z-score and wanted you to find the area. So they were toggling back and forth between, the z-score and the area. They either gave you the z-score and asked for the area, or they gave you the area and asked for the z-score. So what would we do? Stat calculators normal. Okay, in contrast, how do you find a z-score given an x value, a mean, and a standard deviation? So this was more like a story problem. And they'd be like, oh, this woman was 5'4", and the average woman is 5'5", with a standard deviation of 1 inch. What's the z-score? So that's when you would use this formula. Z equals the person in question minus the mean, and we already knew that x bar was mean, divided by the standard deviation. Okay, if they were dealing with a population instead of a sample, then we would use the Greek letters, right? So this would be mu. No, this would, well, what would they use for that? This would be the actual population. I don't know, I'm drawing a blank. But anyways, this would be the mu, this would be the sigma, and I think this is still x for that particular individual or whatever, but I'm not sure. Anyways, sorry about that. Okay, what is a proportion? So I want you to conceptualize what a proportion is. It's a certain amount, it's a ratio of the successes to outcomes. So it'd be like 53 out of 100 people, or 48% of all people, or whatever. So in contrast, we dealt with means was always just an average, but a proportion was always a certain amount of this people out of that people, or they would give it as a percentage. So it's important to be able to identify that a problem is talking about a proportion. Okay, what are the requirements for hypothesis testing? And that, dun, dun, dun. Here we go. Remember this guy? Sometimes they did not have the little P naught. They just had a P depending on the context of that problem. But remember, it was N times P times 1 minus P is greater than 10. The sample size is less than 5% of the population size, which could be written algebraically like this. N is less than 0.05 capital N. And then the sample is random. So they're either going to state that it's random or you would assume it's random. Those were the two options for that. Okay. Oh, let me get back to that one that I fumbled on right here on your formula sheet. This is the one I wrote, x minus x bar over s. If they were in a population, they still use the x for the individual, and then it's the mu over the sigma. So, phew, just didn't want to leave you feeling uncertain about that. All right, the null hypothesis always uses what symbol? The null is always the equals, okay? It was the alternative that was either greater than, less than, or not equal to. How do you conduct a hypothesis test for a proportion using StatCrunch? So if I know I'm doing a hypothesis test and I know it's a proportion, I'm going to do stat, proportion stats, either one sample or two based off of the context of the problem. So remember, one sample just had, you know, a single P compared to the population, and the two sample had a P sub 1 and a P sub 2 compared to each other. Okay, when do you reject the null? When do you reject the null? When the p-value is smaller than alpha. That means that you are rejecting because you have found sufficient evidence. All right. If you see mu sub d in hypothesis testing in the problem, what would you use in StatCrunch? So this is a little indicator that they were dependent, right? So if they're dependent and the mu means mean, that's a t-stat instead of a proportion stat. I would do stat, t-stats, paired is the one where they were dependent. Okay, how do you find the linear regression equation in StatCrunch? Stat, regression, simple linear. Where does the slope go once you find that regression equation? Like once you do it, then StatCrunch gives you the slope and the y-intercept. Where do you put the slope in the equation? It goes right next to the x. So it would be like if the slope was 4, it would be 4x. That's one term. Okay, so the next question is, where does the y-intercept go? Well, it does not go right next to the x, right? It's a constant term. So if you had something like 4 was your slope, that would be 4x. And if your y-intercept was 1, it would be 4x plus 1. The 1 does not go right next to the x. It's its own term. Okay, for every 1 unit increase in the independent variable, so let's say it's the number of colas you drink or something, that would be your independent variable. The dependent variable, well, let's say that's bone density, is either going to increase or decrease by a certain amount. What is that certain amount? What am I interpreting here? I am interpreting the slope, and the slope is what's going to go here. So if your slope is like, you know, -5, then you'd be like, for every 1 unit increase in the independent variable of colas I drink, the dependent variable, the bone density, decreases by 5. Okay, this is the interpretation for the slope. So we put the slope value in the blank. All right, what do you think the next one's going to be? Yep, y-intercept, right? The y-intercept is the value of the blank variable when the blank variable is 0. So it's going to be the dependent, the y, when the x is 0. So it'd be like, well, what's my bone density when I don't drink any colas? Okay, that's how that goes. This is the interpretation for a y-intercept. All right, in a confidence interval, where is the point estimate? Here's my interval. The point estimate is right in the middle, right? Mathematically, how do we find that? We took the mean of the lower and upper bounds. So they use the word bounds, sometimes they use the word limits, the lower and upper limits. So it's the mean, it's in the middle there. All right, whoops, oh, hold on, don't look at that. Okay, in a confidence interval, what is the margin of error? The distance from the point estimate, which was in the middle, to either of those two bounds or limits. Okay, let's see. What do stat t-stats, stat proportion stats, or stat variance stats find? So these three things find the same stuff. It's just that this is for means, this is for proportions, this is for variances or standard deviations. So what do they find in StatCrunch? They find confidence intervals and hypotheses tests, right? Depends on which one you click in there. For means, it's t-stats. Proportions, it's proportion stats. Variances, standard deviation, it's variance stats. How do you find hypothesis testing for distributions using StatCrunch? So if you have a distribution, you remember the example we talked about, like, you know, the bag of Skittles should have 10% browns and 50% purple and 30% yellow and 10% green or something like that, right? So I gave you an entire distribution of percentages. So if I have a distribution and they want me to find a hypothesis test, what do I use for StatCrunch? So think of this as multiple proportions, more than one, more than two. What would it be? Stat goodness of fit chi-square test. All right, what do you use in StatCrunch to create a relative frequency? Graph, bar plot. What's the difference between a parameter and a statistic? A parameter comes from a population, and these are indicators that it's a population. A statistic comes from a sample. These are indicators that it came from a sample. What's another word for Q2? Median, right? That's what they use in StatCrunch. It's also the 50th percentile. It's also the second quartile. Those are all in the same position. They're right in the middle, right? Those are all synonymous words. How do you find the sample size for a proportion using StatCrunch? So if you know it's a proportion and they want the sample size, what's the prompt? Stat proportion stats, one sample with sample size. Now I didn't do a flashcard for this, but what if you knew it was a mean and they wanted the sample size? Then you would do stat t-stats, one sample with sample size. How do you conduct a hypothesis test in StatCrunch for 3 or more means? So we just recently talked about 3 or more proportions, and that was the goodness of fit. 3 or more means would be stat ANOVA one way. What is a type 1 error? It's when you rejected the null and you should not have. What is a type 2 error? It's when you did not reject the null, but you should have. What's quantitative? It's numerical. What is qualitative? It is a characteristic, like a boy or girl or blonde hair or something like that. What's discrete? And by the way, discrete had to have been quantitative. And discrete means it is countable. What about continuous, which is also quantitative? That's not countable because it can be any number, not just whole numbers. And we would, the giveaway is there's some kind of measuring device, right? Like a speedometer or a thermometer or a scale or an odometer. Oftentimes it uses the word meter at the end. So we're measuring something, okay? All right, this isn't really a great flashcard, but can you calculate the areas in a normal curve? So your formula sheet in words will give you the 68% is between the first standard deviations, the 95% is the second, and the 99.7 is the third. So it gives you that in words. It does not give you a picture. But I would recommend that you draw yourself a picture, label your standard deviations. Remember, it's 1, 2, 3, and then there's something else. -1, 2, 3, and then something else. Can you figure out these numbers? Because that will make it easier for you to solve some of the more complicated questions. Okay? And that's it. You can do it. Way to go. You're almost done. Hang in there. Talk to you later.